Hello everyone, I am Riya and my teammates Sanidhya and Samanway. We are going to present on the topic Panorama Stitching, a practical implementation, which is the topic for our image and video processing project. So here are the team members Samanway Maji, Riya and Sanidhya Kumar. Now let's understand what is panoramic stitching. Panoramic stitching, also known as panorama stitching or image stitching, is a technique used in photography and computer vision to combine multiple images with overlapping fields of view into a single wide angle or panoramic image. Now let's understand why we are doing panoramic stitching. So, this process aims to create a seamless and visually continuous representation of a scene that would be difficult or impossible to capture in a single shot. So, here are the applications of panoramic stitching. First, in photography. So, panoramic stitching is used in photography for creating wide angle shots or immersive panoramas. Second, in virtual tours. So, in virtual tours, panoramic stitching is used for generating 360-degree panoramic views for virtual reality or online tours. And last, computer vision. Stitching images for applications like object recognition, scene understanding, and mapping. So these were the applications of panoramic stitching. Now, Sanidhya will tell you how we will do panoramic stitching.
Okay, so now we have learned what is panoramic stitching and why it is used. Now we'll learn how this process is actually done. So, I'll just give you a brief overview of what we would be doing in this presentation. So first we'll learn all the methods which are used in this panoramic stitching, step-by-step implementation we would be telling you. And at the last, there would be a video demonstration wherein we would run the live code and then we'll show you whatever the output, what are the inputs and whatever output we have obtained. So first we'll learn about the theory that how this process is actually done. So how? So the process of panoramic stitching, it involves capturing a series of overlapping images, right? And then we'll identify the key points in all these images, and after identifying the key points, we'll align the images based on whatever the key points we have extracted, and after that we'll stitch stitch all these images together, and we'll finally blend it so that we get a large, a wide image or a panoramic view. So yeah, so to sum this process in steps, so the first step is obviously the image collection, wherein we will capture all the overlapping photos to form a comprehensive scene. The second is we'll do the feature matching. We'll identify and align all the key points in each of these image using methods like SIFT, KNN, and homography. The fourth process is image. Okay, so the third process is image warping. So in image warping, we change the perspective of the images of all the images which are there in the scene. The fourth process is image stitching, wherein we stitch all the images, all the warped images which we have formed. And the last process is image building. Whatever the image we have stitched, now we'll blend it together so that there is no, sudden change in the contrast or sudden change in the brightness. So so all the stitched images look like a blended one. And the last, what we would be getting, it would be a final panorama view. So, so here we can see an example. So the first one, we have collected all the images, discrete images. Second is feature and extraction. We have extracted all the features, the common features in both these, the images. The third step is obviously we are mapping all these images with respect to each other. The fourth step is warping. So here you can see that the image with the red bounding box, it has been warped because the perspective of that image is different. Next, we'll stitch all the images together so that we get an overlaid aligned images. And last, so you can see that here you can see a difference in contrast or brightness. So we'll blend this together so that we get a smooth image, and finally we'll get a blended final image. Okay, so the first step is image collection. Now my friend Samanway would be telling you about the image collection process.
The starting of the experiment, it begins with collecting the images, basically on which we are going to perform stitching. Right. So basically, these are three images that has been taken from a hostel campus, and we can like make out what the three together will represent, and we will just find out in the end whether that aligns with what we are thinking. So step 2 is feature matching. Now feature matching is essentially done by a step called shift. And shift is a computer vision technique, which is specially used to extract features from the images. So how is it done? Basically, it has 4 steps. The 4 steps are scale, space, extrema detection, key point localization, and then we have mode 2.1 orientation assignment and key point descriptor generation. So space extrema detection is done by blurring the images, blurring the separate layers of the images to bring out the essential details like the edges, the contrast, or the hidden features in the image. So after we are blurring it, the next point is to find the key points from those image or the regions. So suppose if we have 3 layers of the image, the key point will be the image, which is the local maxima or the local minima. That is computed by uh, comparing the value with 26 other values, that is the neighborhood ones. The next portion is orientation assignment. So we have the key point, and the key point should be invariant to the rotation. So through this matrix, we can compute the gradient, which is basically the differences of its vertical neighbors and the difference of its horizontal neighbors. And after that, when we get the key point, we take the 16 neighbors of the key point, and we form a key point descriptor like vector kind of structure. So from the previous steps, like these are, if you can see, these are the small points, these are the features that has been extracted from both of the images, and the descriptor matching is matching the related parts of the images with each other, so that in the end, we can combine the two of them. So this is the other part that has been matched. Yeah, so step 3 is image warping. So my friend Sanidhya will take over now.
Okay, so we have understood how we have collected the image and how we have done the feature extraction. Now, the next obvious step is warping the images. So first of all, we'll understand what is image warping. So as you can see in this image, so here let's say I have taken a photograph from two perspectives. The first perspective is this one, the x0, and the second perspective is this x1. Okay, and we have taken the photo of the same scene, which is this green plane, which you can see over here. So the thing is obvious that you will get different perspective of the same plane. And this phenomena that we are getting different perspective of the same plane with respect to different viewpoints is known as homography, and homography defines the relationship between the both of this perspective, which is the x0 and which is the x1. So yeah, for a practical implementation, you can see that we have for this example, this image consists of 3 portions. The first is this left portion, and the second is this middle, and the third one is this right portion. So the cameraman was standing in between, and from the same point of view, we have taken 3 photographs: the left photograph, the middle photograph, and the third photograph. And because of this phenomena, the photograph turns out to be like this. Because what so what this camera does is that it maps this 3D world to a 2D plane, right? And when we are capturing it from different point of view, so it is obvious that the image would get warped. So yeah, so while collecting the images, I was standing in the middle, and I took this left photograph, and after warping, the photographs becomes like this. And for the right hand side, I took this photograph of the right hand side of the photograph, and after warping, the photographs comes out to be like this. So this photograph has been warped as per the orientation of this as per the orientation of whatever final image we are going to form. So once we have done the warping and everything, the next obvious part is image stitching. So we'll stitch all the warped images. The left side of the warped image, the center side, and the right side of the warped image. Okay, so now we'll understand what is stitching. So stitching is nothing. Stitching is just joining all the images which we have formed, and we'll join all these images and we'll form the final image. So as you can see, we have taken this left part, the left warped part, the center part, which you can see here, and the right side warped part, which you can see here. So what we have done, we have just warped all the parts. First of all, we have done the feature extraction, and on the basis of this feature extraction, we have done this warping. And after warping, we have just stitched all the three parts. Yeah, so one thing, when you are stitching all these parts, so you can see that there is a clear distinction between these two images. You can see a line over here, because what happens is that the same camera give different images of would give different images because of several reasons, like vignity, if you are moving on the outer side. So there are various reasons. So because of that, we are getting all these lines. And the next obvious part is blending out these things. So for blending, Riya would be explaining the blending part.
Now let's understand the next part, which is image blending. What is image blending? Image blending is a process in image processing where two or more images are combined to create a new composite image. The goal of image blending is to seamlessly merge the overlapping regions of the input images, ensuring a smooth transition between them. Now, let's see this graph. So in this graph, the first picture is the left portion of the image, and the third picture is the right portion of the image to be blended. And the middle picture is the center part. So as you can see, we will do a linear blending to merge these three components. So here in these two images, you can see in the first image, we can clearly see the boundary or the line between the two images. But so here is the line you can see between the two images. Now, after blending, you can clearly see that there is no line between these images, and these two different images are smoothly merged. Now, let's see the final part, that is final panorama. So, these final steps involves creating the stitched image, adjusting its size, cropping or expanding as necessary, and applying any post-processing enhancement if you want to achieve a visually appealing and harmonious result. So here is our final output, as you can see. Now to extract the full image, we will just crop the black border as you can see in the picture. So here you can see the final blended panorama. As you can see, there is no line between these images. The images are smoothly blended and the black part is also cropped. And this is our final panorama of the images as required. Now Sanidhya will take over.
Okay, so now we have seen what. Okay, so now we have seen all the components which we need to understand the demonstration. So I would be just giving you a quick demonstration of the code and a live implementation as well. Okay, so yeah. So this is the main file, which is image.stitching.py. So what and to match whatever we are doing, to match the feature extraction and everything, we are using this shift matcher as Samanway discussed. We have defined this shift matcher, and you can see the code here. The code is also uploaded on GitHub, so you can see from there. So these are the function. The main function is the matching function in the shift matcher class. And other than that, we are having this image stitching function, which basically stitch all the parts of the images, the left part, the center, or the right part. And one thing I want to point out is that the project which we are building on, it's not only limited to three images. You can provide any number of images, and it will create a panorama out of it. So inside this stitch class, there are various functions, as you can see, and this code is for blending. So whatever stitching is done after stitching all the images, we need to blend it, right? So the blending part is done by it. I'll just give you a brief overview. So whenever there is a function call, so the function takes all the files which is there inside this. So this txt file basically defines all the path of all the images which we have to take as an input for blending, correct? Okay. And after that, it'll go to this stitch class and it will perform the left shift. So in this left shift function, you can see that first we are, so this code is basically for calculating the homography after for the object matching. And this object matching is done by this SIFT, SIFT matching class. So once the matching is done, we'll wrap all the matches which we have obtained all the key points, and after warping, what we would be doing is we would simply stitch all these images. After stitching, what we would be doing is that we would be simply blending all these images. This blending is done by the blend class, which I have shown. And after that, similarly, after the left part is after the left part is merged with the center part. Now, when the left part is merged with the center part, so now the new left part is this new left plus center one, correct? And now this part gets merged with the right one. So the same code goes for the right part. And then after that, there are images for functions to show the images and everything. So I'll just quickly show you a quick demonstration. So as you can see, these are the three images. So this is the left part of the image, this is the center part of the image, and this is the right part of the image. And we have this text file, files 6.txt, which is containing the path to all these three images. Okay. So what we'll do, we'll go to this image stitching class. We'll simply change this path to file 6.txt, and we'll just print the result. We'll do this final. Okay, I'll do this. And then after that, we'll simply run the code. Yeah. And I'll show you what will happen. So we'll get all of the images. Yeah. So first of all, you can see this matrix, this image, which is so the second image is basically the left part. So this is the center part, and this is the intersection part which we'll be getting. And this image tells you about the blending process. So the first image is the right part, the last image is the left part, and the center is, you can see that we are doing a linear blending of the images. And after the key points extraction and everything, so this graph is for, this plot is for key point extraction. So as you can see, we have done the key point matching of all these points. So this point is getting mapped here, and this point is getting mapped here. So all this matching is done. And this plot is finally the wrapped image. So as per the orientation which we got from the key point extraction, we have got this wrapped image for the left part. So, and this matrix which you can see here on the terminal, it is nothing but basically the homography matrix. This homography matrix tells you about the relationship of one image with respect to the another image. In this case, the left image with respect to the center image. So we'll quickly cut that out. And now we are moving to the right part. So we are doing this same for the right part. So the left part now, as I mentioned you earlier, the new left part is this left plus center one. As you can see here, this is the right part and this is the intersection part. And this plot is plot for the blending. So this is the left, this is the right, and this is the center, which is linearly blended. And this is the, okay, I'll get the match plot also. Yeah. So this plot is for the key point matching, which we have done. So as you can see, all the points are mapped. So you can see that this point is getting mapped with this here, the pot, and the right side of the pot is getting mapped with the right side of the pot. So this is done. And the right side is similarly warped. You can see here. And now it says that panorama stitching complete and image saved successfully. So we can see that this new file is generated, final JPG. And this you can see that, yeah, it's a pretty good image which has stitched all the parts together, blended it together, and provided a panoramic view. And if you want to get the final image, we can just simply crop out all the black border which is there on the top and the bottom. And one last demonstration which I would like to show you is for the for stitching 6 images. So we'll not do that now because it takes a lot of computation and a lot of time. I'll just simply show you the input and the output. We have run this for around 10 minutes and we have got the output. So for this, so see here you can see, yeah. So these are the 6 images from I2. All these I2. These are the 6 images. Okay. So yeah, this is the left, the bottom left part. This is the upper left part. This is the middle down part, the center bottom part. This is the center top part. This is the right bottom part, and this is the right upper part. So basically, of the same view, we have taken 6 different photographs, and we would not be able to capture this complete view with the help of one click. So we have taken these 6 shots, and we'll now merge it together. So the final, you can see the final output which we have obtained is this. So you can see that it has perfectly, stitched all the parts, and I'll just cut it out. Yeah. So here you can see that it has blended all the parts together, and it has stitched it beautifully to form a nice panoramic view. So this is pretty much about the implementation part. The code is also uploaded on the GitHub. We have submitted the report on Moodle, and this video is also uploaded to YouTube. So that's all which I would like to conclude. And yeah, that's all. So thank you so much, and we hope that you liked our implementation for the IVP project. Thank you.